Okay, so we're going to go ahead and get started with chapter 7, and we'll start with module 22. All right, and this is on human population. So chapter 6 was all on ecosystems and ecosystem populations. Here we're going to be talking more about just the human population itself and population dynamics. So the human population. After reading Module 22, we're going to be basically talking numbers in this section. And so after this, we'll be able to explain factors that may potentially limit the carrying capacity of humans on Earth. If you remember what carrying capacity was, it would be the resources needed to sustain life in an ecosystem of a population. So when we talk about human population, what are the things we need as humans to survive? We're going to describe the drivers of human population and growth, what causes population growth, and we're also going to read and interpret an age structure diagrams. So, scientists disagree on exactly what Earth's carrying capacity is. Under ideal conditions, like I said in the previous chapter, populations grow like this. They grow exponentially. They will go up. In most cases, though, exponential growth either stops or slows when an environmental limit is reached, the carrying capacity. So instead of going straight up, it will level off. All right, but you can see here in the history of human population, humans had a pretty almost linear curve for the most of its growth. And then, you have a little dip here for the Black Death and the plague. All right. But what you see is, fairly good growth. And all of a sudden the Industrial Revolution hits and we skyrocket. We go J curve on that. With us being, though, a K-selected species, a species that meets all the criteria for that. We do, however, expect it not to come crashing down, but to level off at some point. Where is it going to level off? We're going to talk about that. So in order to understand the impact of the human population on the environment, which is our main goal here, we must first understand what drives human population growth. So the factors that drive population size include, that drive population growth include the population size to begin with, and this would be in different countries, birth and death rates of the countries, fertility, life expectancy, and migration in and out of the country. So when we talk about these factors, the study of this type of stuff is called demography. And it's the study of human populations and population trends. And a demographer is a scientist who studies these population dynamics. So what are the things that cause change in population size? We've got immigration, which is the movement of people into or out of a country or region from another country or region. Emigration, which is going to be the movement of people out of a country or region. Those are fairly minimal. They do contribute to a population of a country. However, they're minimal compared to the crude birth and death rate. And so these are going to be, our major indicators of what's happening there. The number of births per 1,000 individuals per year is the crude birth rate, and the number of deaths per 1,000 individuals per year is the crude death rate. The reason that we use per 1,000 individuals is so that the numbers are easier to work with when we do our calculations. So you can see here the ins and outs of population size, with births and deaths usually being the bigger factors. So obviously if you have more immigration and a higher birth than death rate, your population size will increase. However, if the others are bigger, the immigration and deaths, you'd see a population decrease. And so the human population pretty much is a system. If you think of it as a system, the births and immigration are inputs and the deaths and emigrations are outputs. So these are the calculations that you may need to know. These are in the book. Make sure that if you have any questions that come along with these calculations, you know how to do them. It's really kind of easy. The global population growth rate is going to be the crude birth rate minus the crude death rate divided by 10. The national population growth rate is the crude birth rate plus immigration together minus the crude death rate plus emigration together divided by 10. So that's going to be for a nation. Obviously, you don't have immigration and emigration for global. because we don't have any aliens coming in and out that we know of. And then the doubling time, it's a very interesting equation. And if you have any questions about how they actually came up with this, I did derive it myself a few years ago just to double check because I thought it was so cool. But doubling time, it's the number of years it takes a population to double. And what it's going to be is it's going to be 70, the number 70 divided by the growth rate. And it gives you a very good estimate of how many years it takes you to double. All right, so the total fertility rate. Fertility is going to be, of course, the measure of how many children people are having, and so they do this based because the women have children. They do it based on women and not men. So what they do is it's an estimate of the average number of children that each woman in a population will bear throughout her childbearing years. So they take the average childbearing years for our population, and then they over that span of time, they'll do statistical analysis of how many children on average each woman is having there. Replacement level fertility is the total fertility rate required to offset the average number of deaths in a population in order to maintain the current population size. It's not always 2. You'd think it'd be 2 because, that would be replacing each man and each woman. However, if your death rate is really high or is really low, that number will change. So replacement level fertility does depend on the conditions you are living in. The replacement level fertility tends to be higher in developing countries because mortality among young people tends to be higher as well. So what is our projected world population growth? So demographers project that the human global population by the year 2100 will be between 8.1 billion and 9.6 billion, by 2050. By 2100, it's expected to be 6.8 and 10.5 billion. But as you can see, both of them do not continue the J curve up. Both of them, even the high estimate, the highest they suspect it to be, even flattens out. So we are reaching a point where we're not going to be continuing that curve, and we'll see why as more and more countries move through what we call the demographic transition. Life expectancy is another term, like I said, that factors into population. Life expectancy is the average number of years that an infant born in a particular year in a particular country can be expected to live, given their current age, lifespan, and death rate in that country. This number goes up. It goes up as a country gets more and more and more developed. They get better access to healthcare. They get better access. They get better quality of life, basically. And so what happens is that life expectancy will rise. Infant mortality is the number of deaths of children under 1 year of age per 1,000 live births. This and child mortality, which is the number of deaths of children under age 5 per 1,000 live births, are going to get, they're going to be fairly high for developing countries. And as countries get more and more developed, these numbers start to drop for the same reasons that life expectancy increases. As you can see around the world, most MEDCs, or developed countries, are going to have above 75 average years life expectancy. And as you can see, there's places in Africa that you've got less than 50. So you've got major discrepancies in MEDCs versus LEDCs in terms of life expectancy. Migration. Regardless of birth and death rates, a country may experience population growth, stability, or decline as a result of net migration. So the net migration rate is the difference between immigration and emigration in a given year per 1,000 people in the country. All right, so what are age structure diagrams? They're actually a really cool way of representing the where a country is in terms of its population. Is the population, are a lot of them dying young? Are they living to old age? Has there been any event that has caused a dip in population? That's where we get through these. So an age structure diagram is a visual representation of the number of individuals within specific age groups for a country, typically expressed for males on one side and females on the other. And so you group them. You group them in, I think I talked about this in the last chapter, You group them in terms of like 0 to 5 years old, 5 to 10, 10 to 15, 15 to 20, and you put the number of individuals on two sides of a diagram. We'll show it there. This forms what we call a population pyramid. So a population pyramid is what's typical of an LEDC. It's where that's widest at the bottom and smallest at the top, meaning the bottom being your younger people. That means there's a lot of young people, and it drastically reduces as it goes up because people are dying younger. Population momentum is continued population growth after growth reduction measures have been implemented, and we'll see that in some of these diagrams. So you can see here, A is indicative of India, where you have massive population growth happening right now. But you can see right here, all right, and the left is the male, the right is the female. You can see those 0 to 5-year-old, 5 to 10-year-old, those are big numbers, right? They go all the way out over here in the 55, 60 million range, right? But you can see drastic reductions as you get older with not many people making it even above like 50. So there's a lot, there's a big change going on there. You can see now we got an MEDC, United States, right? What you see in indicative of an MEDC is instead of a very like wide bottom, you'll see pretty much straight going up until about age 50 to 55, same proportion of people. Even you'll see, and we'll see this in the next one, Germany, you might see like a little reduction right there, right? And then it starts to decline as people get to actual, old age. You can see in some developed countries, you will see a large amount in the middle, all right? And so what you're seeing there is that people are having less children in Germany. And so their population is actually decreasing. People are having less children. So because they have good health care and stuff like that, you've got a larger amount of population here in the middle with a smaller amount of populations and the typical trend at the top. Now, China, like I said, that's like they are in the middle of an MEDC, LEDC, so you don't see the perfect, like not perfect, but I mean, you don't see the typical like India pyramid shape, but you do see a bit of a pyramid. You definitely see people not making it as old as they make in the United States and Germany and stuff like that. But they have had population control measures in their country where they really encouraged people, some people think unethically, to have less children. And you can see that that has caused a drop, kind of like Germany, but for different reasons than Germany. This was like government enforced in China, whereas in Germany it was just natural. And that's it for Module 22, and we'll conclude the population lectures, human population lectures with Module 23.